তেখেতে যিখিনি কথা ক'লে আমিও সেই লাইনতে ভবা আৰম্ভ কৰিছোঁ আৰু তেখেতে যিখিনি আমাক মূল্যৱান অন্তৰ্দৃষ্টি নিক্ষেপ কৰিলে তাৰ জৰিয়তে আমি নিশ্চয় উপকৃত হ'ম বুলি মোৰ দৃঢ় বিশ্বাস। আৰু আগলৈ আমি ভাবোঁ তেখেতসকলৰ দিহা পৰামৰ্শ লৈ আমি এনেকুৱা লেভেলত কাম কৰিবলৈ আগবাঢ়িব পাৰিম। আমাৰ মাজত উপস্থিত আছে ডক্টৰ ববি শৰ্মা মেডাম, এছ'চিয়েট প্ৰফেচৰ আছাম ডন বস্কো ইউনিভাৰ্চিটি। মেডামক আহি তেখেতৰ বক্তৃতা ৰাখিবলৈ অনুৰোধ জনালোঁ।
Very good evening to one and all present here. First of all, I'd like to give my heartfelt thanks to the organizer for giving me the opportunity to stand here and to speak few words on the subject of my interest. Here I have chosen the topic Basic IoT, IIoT as well as Industry 4.0. I thought the talk will be basically for all set of background, but when I come to know that all the audience are from the background of computer science, I'll try to, of course according to the slide it will be very basic, but since it is my area of interest, we may have to discuss something in details if the time as well as the situation permits. So I want to keep only the 3 points here: Internet of Things, Industrial Internet of Things, as well as Industry 4.0. Because these 3 topics are revolutionized and it has been implemented in different industry all around the world. We can't think of the world, we can't think of the industry nowadays without having any communication. Especially during the time of pandemic, we have seen everything was automated. Still, everything is in a blended mode. Physical observations as well as going to somewhere, doing something is little difficult for us, maybe because of several obstacles in between. Hence, it is mandatory for us to implement the smart system all around. We have been working in this particular field for some years, and even we have published some papers basically based on Internet of Things as well as sensor networks, and these are all related. When we speak about the Internet of Things, what we basically understand, it is nothing but connection of different sensor nodes together under some wireless communication system. When we say the sensor node, it is not all about the sensors. Of course, we have some sensors which are commercial sensors where chipsets are already integrated. Otherwise, what we have to do, we have to connect the different sensors along with the microcontroller, and this microcontroller is supposed to have the Wi-Fi system, or it may have to work with some radio spectrum through which it can establish communication amongst the different sensor nodes, and finally it may communicate to the cloud system, and from the cloud system data can be downloaded or data can be utilized for various purposes in the different handheld devices, including mobile phones, laptops or other devices. So how exactly IoT works? Basically, it is nothing but these are some sort of sensors already I have mentioned, and moreover we need the connectivity, and this connectivity is based on some radio spectrums already I have said, and data processing as well as user interface. So what about the sensors? Basically the sensors collect the data from the environment. Suppose if I want to come to know, is there anything happens in this room? Is there some sort of gas is gas is found in this room? In such situation, how can we exactly come to know? Definitely, we need some sensors via which it can collect data from the surrounding, put it in the microcontroller, and then through the microcontroller data will be processed, and finally it may send to some of the gateway, and then from the gateway it may go to base station, or then it may go to cloud, and finally it can be extracted by the different users with the help of different devices. So for every different purpose, we have a different sensors. Even in our microcontrollers, we can fix the different sensors together, and all the sensor may work at a different point of time as per the rule established or rule fixed by the users. Now this is one of the scenario for connectivity. To have the connection, obviously we need radio wave, or you can say radio spectrum or electromagnetic spectrum. So what sort of electromagnetic spectrum we may need? As for example, if we want, we can work with the microwave, radio wave, Bluetooth, Wi-Fi, except X-ray, gamma ray, etc. Because in case of X-ray, gamma ray, etc., although we have a very high frequency, although we can utilize this for communication, since these are very harmful for the human as well as living object, so we have to avoid. But apart from that, other radio electromagnetic spectrums can be utilized for communications. Now about the data processing. Data processing is nothing but collection of data, and generally for all the different sensor nodes have some sort of tiny operating system, because it is quite difficult for us to supply or to provide external power source to the node. If we suppose segregate this node in some hazardous area where human intervention is not possible, in such situation it will have to depend on the battery backup. Due to some reason, if high processing or maybe some extra work it will have to do, there is a chance of having the battery degradation. As a result of this, the life of the node will be getting down. Hence, we need some tiny operating system with the help of which it can process data in a very minimum way, and finally, with the help of multi-hop communications, it can forward data to the gateway as well as to the base station. So what is that multi-hop communication system? Multi-hop communication system is nothing but, it's a kind of protocol like AODV, or you can say ad hoc on-demand distance vector routing protocol, in which the different data will be forwarded one after another, because in the short range we need the different nodes to be very near to each other, and finally it may reach destinations. Now obviously the people like us who will work in the interface, or who will work or will get the data in a different handheld device, we need a very user-friendly interface. Obviously, we understood about the benefits of IoT. Basically, it helps us to monitor the data, as well as it helps us to get a very good connectivity without having any human intervention. It saves time and money. It enhances the employee productivity and so on. Now let us come down to industrial IoT. Since we understood IoT or Internet of Things can be implemented in a smart home or maybe very small office, right? But if we have to control the entire industry from the remote area, and if we want to see what exactly going on in the industry, how the data can be controlled, and even what are the other devices, which are the mechanical device, electronic device can be controlled remotely, then we have to think of industrial IoT as well as Industry 4.0. Now in this diagram, there might be a question whether it is an evolution or revolution. Application of Internet of Things or IIoT, Industry Internet of Things, is an evolution or revolution. According to me, it is an evolution. Right from the beginning till date, if we see how the integrations, how the different softwares, hardwares are developed, and how it can be implemented to the different industry, different offices, and how the user has taken up. So that way, if we see, it's a kind of evolution, and in the other hand, some people may say that it may be a revolution. Whatever it is, if we see from several years back, maybe 10 years back, what we got and what we are now, we can see a vast difference. Now, if we see the industrial IoT, already I told, step by step we are moving forward. We got the concept, say IoT, now it is all about industrial IoT. When we speak about the industrial IoT, it is basically a network of different smart nodes. At the same time, we have to operate with the actuators. So what is the actuators? Suppose there is a device which is far away from me, or maybe from distance, if there is a distance in between. Now if I have to operate the device from this location, as for example, we have developed one device that is an automated elephant system. We are supposed to get the patent for this device. We have filed the patent, it takes time, so that's why we are waiting. In that particular device, when we place that smart node just beside the railway track, it knows that elephants are moving towards the railway track, and it knows that train is also approaching, and that situation automatically control can be alerted to the monitoring system or to the office of the station masters. And the station master immediately manage the railway driver to stop the train so that there will not be any head-on collision between the train as well as the elephants. So this sort of application where we do not need any human intervention, even the different nodes what we place around, they can communicate amongst themselves to get a gateway, and from the gateway the message can be forwarded to the station masters. So why industrial IoT? First of all, industrial IoT is collaborative. And why collaborative? Because it can work together with the different sector of implementation, maybe the cloud computing, cyber security, AI, ML and other related fields. It will make the business sustainable. Always we need not have to depend on a human. There might be a question in our mind. If we go and implement similar kind of technology, will it be difficult for us to survive? And I say no, because we have to upgrade ourselves. We have to know how to work with the new technology. At the same time, I'm sure it will increase the employability. It will generate the value for business, of course. It generates efficiency and improve the operations, improve the customer service, and most importantly, it can be used for the maintenance and the preventive purpose. And also the remote updates, monitoring and control, and production quality can be enhanced. Now in the manufacturing field, previously when we have implemented the SCADA, SCADA, the term may be very much popular amongst the staff, that time implementation of robotics in the field of manufacture was basically to do a specific purpose. Now the same robotics along with AI, ML and industrial IoT, it can be implemented for multiple purposes. Not only to fix the different devices, but to observe the quality, to observe the inventory, or to maintain the productions. For all different purposes, we can use the same robots. And that's why it is industrial IoT. It's not the simple IoT that we are going to implement. For the utilities, especially in your case, probably you have already implemented, I'm not aware, use of the smart grid along with industrial IoT. We know the purpose of smart grid, but how we are going to manage and maintain that smart grid? If we can implement industrial IoT in our smart grid, it is not mandatory for us to go and see everything by ourselves. We have seen the smart meters which are already fixed in our house, and gradually I am very happy that ASAP or APDCL is gradually upgrading, and they have renovated their industry in a very different way and very quickly and promptly. And one day it will come where the full form of industrial IoT can be implemented in the smart grid. This is the scenario of the smart grid, as you have seen, how we are going to connect, or when the production is going on, how much production is there, what is the capacity, if it is beyond capacity, how it can be transmitted to other purpose, and everything can be managed by implementation of industrial IoT. Similarly, for oil and gas sector also, we have seen they have fully used industrial IoT, especially during the time of COVID. The Kuwait oil company, with the help of the Siemens company, they have implemented industrial IoT in their companies in such a way that nobody will have to go there and fix the nut and bolt by staying in that particular area. Instead of that, they can manage and they can fix this remotely because sensors are already fixed. What they have to do, they have to control it from the distance. Of course, the rule must be fixed by the users. If the rules are wrong, obviously the entire implementation will be wrong. And for this, the programmer like us and the people from computer science, IT, as well as from electronics background, supposed to work hard. In the logistic, it is vastly used. Even in the library also, we have an RFID, all of you know, right? With the help of that RFID, we know which book has been issued, how the inventory is being maintained, what are the different borrowers to whom we have issued the book wrongly. Everything can be tracked and managed. And smart building, I did not have to say, all of you know. Now let us see the revolutions. First of all, Industry 1.0. Then it has come up with Industry 2.0. Then Industry 3.0 and now Industry 4.0. And why Industry 4.0 is important? Because it is working on augmented reality. Probably the term is very much familiar with you all. Augmented reality means we can get the image in a 3D view in our screen. As for example, doctor is doing surgery without having the patient physically. In that case, how it is possible? It is only because of the augmented reality. In case of augmented reality, the entire images will be displayed in my screen as if like a real image, and it is a 3D view. Doctor will have no knife in his hand, but he can operate the operation by giving the instruction. At the same time, it will be operated in the operation theater, which is remote or which may be far away from the doctors. And mostly because of the augmented reality, the industrial IoT is very, very familiar and popular. So this is all about Industry 4.0. Now the transition has come up from Industrial IoT to Industry 4.0. As you have seen in the diagram, it started with a robot, then human-machine interface. After that we have a sensors, we have a monitoring tool, we have an instrument, control system together. And whatever the data that will be collected by the different sensor, as Professor Neok told, how the big data or the machine learning technique, AI technique, deep learning, etc. can be implemented with the collected data, and after that you can predict something, manage the data. But thing is that, as he said, which technique to be used, it is totally dependent on the user. It's not just because that we are going to implement the machine learning and the deep learning. If my data is not that big, why should I go for a very high process CNN model? Maybe the other deep learning model like VGG16, etc. Right? So in that case, we have to choose which model will be fixed for my purpose. So augmented reality, already I have explained, you have seen the diagram. Without having the patient, doctor can do the surgery. It is only because of the augmented reality that we have. Now what about the global scenario? How the people have adopted the industrial IoT in their areas? If you see, 35% are currently collecting and using data generated by the smart sensor to enhance manufacturing as well as operating process. 70% believe it is extremely or moderately important that US manufacturers adopt an IoT strategy in their operations. And similarly, other countries are also already adopting these techniques. And even India also, many industries have already adopted industry IoT or as well as Industry 4.0 in their manufacturing industries. So current IoT landscape in manufacturing, one of the famous and the popular is Airbus Factory for the Future. They have already implemented a project named as MIRA, that is Mixed Reality Application Tablet, through which, with the help of